Imagine a pipeline longer than the distance from New York to Miami, cutting through one of Africa's most unforgiving mountain ranges. Morocco is building exactly that. An 1,800-kilometer water highway that moves enough fresh water to fill 400,000 Olympic swimming pools every single year. We're talking about crossing terrain where temperatures swing 50 degrees Celsius in a single day, drilling through mountains that rise over 4,000 meters high and creating an artificial river system that could transform an entire continent. Keep watching, because you're about to discover how Morocco is engineering one of humanity's most audacious answers to the water crisis. Did you know that North Africa is facing one of the planet's most severe water emergencies? In just 2 decades, Morocco's water reserves have dropped by 80%. Let that sink in. 80% gone in 20 years. The southern regions, home to some of Morocco's most fertile agricultural land, sit parched and dying, while northern areas experience seasonal flooding that simply washes away unused. Over 10 million Moroccans lack reliable access to clean water, and agricultural output has been plummeting year after year. The numbers paint a stark picture. Morocco's existing infrastructure loses a staggering 40% of its water to leaks and evaporation before it ever reaches people who need it. Climate change is accelerating desertification at rates scientists didn't predict even a decade ago. Historic droughts in 2016, 2020, and 2022 devastated harvests and cost the economy billions of dollars. Meanwhile, the Atlas Mountains, that magnificent spine of rock dividing the country, has historically separated the water-rich, prosperous north from the struggling, thirsty south. This isn't just about inconvenience. This is about survival. Morocco's ambitious 2030 vision demands complete food and water independence, but achieving that seemed impossible with the country literally split in two by geography. The government knew that without a revolutionary solution, regional instability would intensify, agricultural collapse would accelerate, and millions would face an impossible choice between migration and desperation. Morocco didn't arrive at this mega project without trying everything else first. Over the past 50 years, they built 149 dams across the country, creating what should have been a comprehensive water storage network. But here's the harsh truth. Siltation reduced their capacity by 30%, and dams can't move water where it's actually needed. They're stuck in place while the water crisis is mobile and growing. The country then pivoted to desalination, constructing 12 coastal facilities to turn seawater into fresh water. The technology works beautifully on the coast, but pumping that water inland, especially up and over mountain ranges, proved prohibitively expensive and energy-intensive. Drip irrigation programs helped farmers use water more efficiently, but efficiency means nothing when there's simply not enough supply. Groundwater extraction seemed promising until overpumping caused aquifer collapse and saltwater intrusion, making the underground reserves unusable. International aid projects came and went. Small-scale, fragmented efforts that never addressed the systemic distribution problem. They even experimented with cloud seeding to generate rainfall, but the results were minimal and completely unreliable. After solving X, Morocco faced an even bigger challenge. Each solution had addressed symptoms, but never attacked the core problem. Morocco has water, but it's in the wrong place. What they needed wasn't just storage or generation. They needed to fundamentally redesign where water flows across their entire country. Morocco's answer is breathtaking in its ambition. The National Water Plan envisions an 1,800-kilometer interconnected pipeline network that will span the entire country coast to coast. This isn't a single pipe. It's an intricate system starting at water-rich northern dams like Oued Martel and Lucos, piercing straight through the Atlas Mountain range, where peaks exceed 4,000 meters in elevation, and terminating in the parched southern agricultural zones right at the edge of the Sahara Desert. The strategic route connects 8 major regions and more than 40 cities, designed to redistribute 1 billion cubic meters of water annually. To put that in perspective, that's enough water to fill over 400,000 Olympic-sized swimming pools, or meet the annual water needs of nearly 20 million people. The scale is 3 times longer than California's famous State Water Project, but it's pushing through terrain 10 times more hostile and unforgiving. Here's where the engineering gets truly impressive. The main arteries use massive 3.5-meter diameter pipes, wide enough to drive a small car through. Constructed from reinforced concrete and steel, designed to withstand extreme pressure and temperature variations. The system requires 47 pumping stations strategically positioned to lift water over mountain mountain peaks that would make climbing Everest look modest by comparison. These aren't small pumps. Each station is a facility the size of a city block, running continuously to maintain pressure across hundreds of kilometers. The most remarkable achievement is how they're conquering the Atlas Mountains. Engineers are drilling 23 underground tunnels through solid rock, with the longest stretching 38 kilometers. That's nearly 24 miles of tunnel, boring through one of Earth's oldest mountain ranges. Imagine the precision required. Tunnel boring machines working in conditions where temperatures can swing from freezing to scorching, where the rock composition changes every few hundred meters, and where a miscalculation of even a few degrees means two tunnel sections won't meet in the middle. The system incorporates advanced sensors every 5 kilometers for real-time leak detection, because losing even a fraction of this precious cargo to the mountain rock would be catastrophic. Where the terrain allows, gravity-fed sections reduce energy needs, letting nature do the work as water flows downhill. At 15 strategic points along the route, treatment facilities ensure the water remains pristine from source to destination. There are even parallel emergency backup systems. If one section fails, water can be rerouted to keep flowing. What makes this truly 21st century engineering is the smart control network, using artificial intelligence to optimize flow in real time. Sensors constantly monitor pressure, flow rates, temperature, and water quality, making micro adjustments thousands of times per day to ensure maximum efficiency. The total length of pipe is enough to circle Earth's equator. We're talking about moving the equivalent of 400,000 Olympic pools worth of water every single year through some of the planet's most challenging terrain. But the pipes themselves are just the beginning. To make this vision reality, Morocco is constructing an entire ecosystem of supporting infrastructure that's almost as impressive as the main project. They're building 17 new water treatment plants, equipped with cutting-edge filtration technology, representing an $800 million investment in ensuring water purity from mountains to city taps. Energy was the next challenge. How do you power 47 massive pumping stations without creating an environmental disaster? Morocco's solution is ambitious. 380 megawatts of renewable energy farms combining solar and wind power, strategically positioned along the route. The entire project must achieve carbon neutrality, turning what could have been an environmental burden into a showcase for sustainable mega-project engineering. That's enough renewable energy capacity to power a city of 600,000 people, while moving water across an entire country. Consider the logistics nightmare of building in the Atlas Mountains. They had to construct 600 kilometers of access roads just so maintenance crews and construction vehicles could reach remote sites. 12 storage reservoirs positioned at key elevation points provide buffer capacity totaling 200 million cubic meters. Insurance against drought and demand spikes. A telecommunications network, including fiber optic cables, runs alongside the pipes, enabling real-time monitoring of every section of this massive system. In the most remote mountain zones, they literally built cities to house over 15,000 construction workers, complete with housing, medical facilities, and supply lines. 4 new rail connections were required just to transport construction materials to sites where roads couldn't reach. The total official cost estimate stands at $12.4 billion, though analysts suggest the final bill will likely exceed $18 billion. To put that in perspective, that's roughly equivalent to 15% of Morocco's entire annual GDP being invested in solving their water future. If completed as envisioned, this water highway doesn't just move water. It transforms an entire nation's destiny. Economists project a $4.5 billion annual boost to GDP from agricultural productivity alone. Over 600,000 hectares of new farmland could be irrigated, turning Morocco from a food importer into a significant exporter. That's an area larger than the entire country of Brunei, suddenly becoming agriculturally viable. The job creation numbers are staggering. 350,000 direct jobs during construction, and an estimated 150,000 permanent agricultural jobs once operational. But beyond the statistics, imagine what this means for actual communities. Villages in southern Morocco that have been slowly dying as young people migrate north in search of water. An opportunity could see complete revitalization. Rural families who've known water scarcity for generations. Tourism stands to boom as well. Water security enables sustainable tourism expansion across the south. Those ancient kasbahs, stunning desert landscapes, and mountain valleys could welcome visitors without fear of overtaxing local resources. Morocco sits just 150 kilometers from Europe, across the Strait of Gibraltar, perfectly positioned to become a stable agricultural supplier to the European market, but only if they can guarantee consistent harvests. The environmental benefits extend beyond human needs. Reducing over-extraction of groundwater could restore wetlands that have been drying up for decades and prevent the total collapse of aquifers that took millennia to form. There's even hydroelectric potential built into the system. As water descends from mountain heights, it can spin turbines, generating clean electricity as a bonus benefit. The harsh truth is that building through the Atlas Mountains presents challenges that would stop most projects dead. Morocco sits in a seismically active zone, requiring engineers to design flexible joints that can absorb earthquake shocks without catastrophic failure. Temperature variations in the mountains cause massive expansion and contraction in pipes. Materials must handle both freezing mountain winters and scorching summer heat without cracking or bursting. Many construction sites are so remote, they had zero infrastructure when work began. Everything, equipment, materials, workers, food, fuel, had to be helicoptered or trucked in over newly built roads. At elevations exceeding 4,000 meters, altitude affects both machinery performance and human workers. Equipment operates at reduced capacity in thin air, and construction crews need time to acclimatize or risk altitude sickness, affecting their precision work. Flash floods present another danger. Mountain valleys that look dry and safe can become raging torrents within minutes during sudden storms, threatening both workers and partially completed infrastructure. 3 tunnel-boring machines, each costing tens of millions of dollars, have already broken down in the harsh geology, requiring complete replacement. Yet after solving each challenge, engineers push forward, adapting techniques and learning as they go. So where does this mega project stand today? Phase 1, covering the northern section of roughly 400 kilometers, is 60% complete as of 2024. 8 pumping stations are fully operational, and 2 major tunnels are finished and flowing with water. Early sections are already delivering water to previously underserved northern communities, proving the concept works at scale. Phase 2, the Atlas crossing that represents the project's greatest challenge, sits at just 15% completion. The original 2025 completion target has been pushed to 2030, with some analysts suggesting 2035 is more realistic given current progress rates. Worker strikes over harsh mountain conditions have caused delays. Funding freezes have periodically halted construction as the government manages cost overruns. Initial water flow rates have come in about 30% below projections, partly because drought conditions in the source regions mean less water is available to redistribute. But this doesn't represent failure. It represents the reality of building something that's never been attempted before. Every mega project in history, from the Panama Canal to the Three Gorges Dam, faced setbacks and adaptation. What matters is forward momentum, and Morocco continues pushing ahead. The world is watching Morocco's gamble with intense interest. France has secured major construction contracts. Spain, heavily dependent on Moroccan agricultural imports, supports the project's success. The UAE has provided investment capital, seeing strategic value in a stable North Africa. China supplies equipment, eager for a successful showcase of infrastructure capability on African soil. The World Bank has extended conditional loans, betting that completion is achievable. If Morocco succeeds, this becomes the model for Egypt considering Nile redistribution, for Pakistan working on Indus River management, and for India planning massive interbasin water transfers. The UN Water Agency is monitoring closely because this project could either validate or discredit the entire concept of human-engineered water redistribution at continental scales. This is strategic brilliance in action. Morocco isn't just solving a domestic water crisis. They're positioning themselves as the African leader in climate adaptation engineering. Success here means influence, investment, and international prestige. It means proving that human ingenuity can overcome geography itself. What's remarkable is that Morocco's water highway doesn't just represent one nation's solution. It's a blueprint for how humanity adapts to climate change. Regions across Africa, South America, the Middle East, and even parts of the United States face similar water distribution problems. Morocco is demonstrating that we don't have to accept nature's water placement as permanent destiny. Imagine if similar water highways connected the Congo Basin's abundant water to the Sahel's desperate need. Picture the Amazon's massive flow being partially redirected to South America's Atacama Desert, the driest place on Earth. Consider California using a Morocco-inspired system to move northern water south, without the political paralysis that's blocked progress for decades. The technology exists. The engineering is proven. What's needed is the same combination of vision and determination Morocco is displaying. If countries work together, sharing technology and lessons learned from Morocco's experience, interconnected water highways could become a global adaptation network. This isn't science fiction. It's engineering in progress right now, just a short flight across the Mediterranean from Europe. Morocco stands at a defining moment. The project is too far advanced to abandon without massive economic and political consequences. Yet finishing requires sustained commitment through 2030 and beyond. Every kilometer of completed pipeline is a testament to human capability to reshape our environment, not through destruction, but through intelligent redistribution. The engineers working in those Atlas Mountain tunnels aren't just moving water. They're proving that humanity can face climate challenges with solutions as bold as the problems are severe. When completed, this system will bring water security to millions, revitalize dying agricultural regions, and demonstrate that geographic limitations can be overcome through ambition, technology, and unwavering determination. So what do you think? Is Morocco's water highway the model that other water-stressed nations should follow? Could you see similar projects transforming other regions facing water scarcity? Imagine the possibilities. Artificial rivers crossing continents, bringing life to deserts, and proving that human innovation has no limits. Leave a comment below and share your thoughts on whether this is the future of water security. And don't forget to subscribe so you don't miss more incredible stories about how humans are using engineering and technology to overcome nature's greatest challenges and build a more sustainable future for our planet.